So I now want to compare f with f prime graphically. The reason I want to do this is that many people who first learn about the notion of the derivative as a function itself are surprised by just how little the graph of f prime seems to have to do with the graph of f. They never really look very much like each other. So I just want to show you what the actual relationship is so that you can see it. Remember that f prime is giving the slope of the tangent line at a particular value x. So here what I've written in is I've written in a blue function y equals f of x, and I'm going to draw a purple function on top of it that is f prime. So let's just put in some lines here. Let's take a look at, let's say, at that point. And here we've got a very steep tangent line. I'm going to draw this a little bit smaller so that it doesn't take up too much space. But you can see, even just from that little fragment of the tangent line, that it's very, very steep. So if you had to eyeball the slope of that line, let's just give it a number. I'm going to say that it's about 10. So that means I can put in up here a purple point. That is on the graph of f prime of x. In other words, right over where this is the tangent line. In other words, for whatever value for whatever value of x that is, where we're getting a point on the curve y equals f of x, right over that point, I'm going to say what the slope of the tangent at that point is. Now let's go over here. If I look at this point here, I'm going to get a slope that's somewhat smaller. It's positive, but it's very small. I would say it's about 1. So I'm going to put in a value for f prime of x that's equal to about 1. And so let's move on. Up here, the tangent line is really horizontal, and we know that a horizontal line has a slope of 0. So for the purple function, I can put in a y value of 0 right there. Now, let's move over to here. What is, at this point here, what is the slope of that tangent line? That's going to be a negative number, which looks like it's about there. I'm going to say it's about -1. And over here, it looks like the function's actually, it still has a negative slope at this point, but it's kind of a very shallow one. It looks like about -1/2. So I'm going to put in this point here, -1/2. And we'll go over to here. At this point, what's the slope of that tangent line? It's going to be about, that looks like 0 again. So here comes the purple point crosses there at 0. And here we're back to, it looks like a tangent line slope of 1 again. So I'm going to put in another point at 1. And finally, let's go over here. We have a tangent line. It's pretty steep. It's not as steep as this line, but it's still pretty steep. So I'd call that maybe an 8, just like how over here we call the slope at 10. I'm going to call this one an 8. So that's going to be about, comes out right about there, right where the function is actually. Now if I draw this in, I'm just going to connect these dots in as fluid a curve as I can. We see that the purple function is the derivative of the blue one. And as you can see, they don't really look very much like each other. The purple one looks kind of like that. And the blue one, on the other hand, looks kind of like that. It's like they don't really share a shape. You know, one is a U and one is this kind of ribbon that goes up, it goes down, it goes up again. So the functions don't look very much like each other, and yet it's still possible to figure out from one of them what the other one is. In particular, by just looking at the slope of the original function, you can figure out what the slope of the derivative looks like.